All right, so let's jump right into what is combustible dust. And a good analogy for the combustible dust problem is to envision the idea of a log burning, maybe in a fireplace at home or at a campfire. Most of us have experience with this. We understand that the log burns, it gives off heat over a long period of time, but it's not particularly easy to ignite. You can't just take a match and light it up immediately. So what we end up doing is we chop some of that wood up into smaller kindling, or we go out and we find some leaves or something that's got a little bit more surface area, something we can use a match to light. It gets going and it provides that starting heat for the log to begin burning. Now, if we extrapolate that out even further, we talk about chopping that kindling down into a real fine powder or a fine dust. We go out to the parking lot, we disperse it into the air and we light it up. You'll see that it ignites and it burns almost immediately. And that's because the amount of surface area is going to play a huge role in how quickly that occurs. So the key thing here is that it's about how much mass there is within your combustible dust that determines how much energy is released. And if you release that energy much more quickly, it's going to do more damage. So when we define what a combustible dust is, you'll see that most publications will talk about the range below 500 microns as what we consider to be dust. So if you've got a finely divided particulate solid below that 500 micron level that can burn, that can pose a flash fire or explosion hazard when it's suspended in air, that's what you're going to be labeling as combustible dust. Now this can be any number of things. As you see here in our list at the bottom, it could be everything from agricultural products like sugar, grain, or coffee. It could be something in the plastics or the rubber compounding industry. And it could be something like aluminum or other metal dusts. So it's got a broad reach in terms of what there is that could be defined and considered to be a combustible dust. And those hazards need to be understood. And each industry kind of has its own set of combustible dust challenges that they're grappling with. So we're all pretty familiar with the fire triangle. We understand what it is to require fuel, air, and ignition source. And you see here in this dust collector, this comes from our neighbors up in Canada, who, in this scene, we've got a fire in the dust collector. That fire is being fought by these firefighters. They're using their hoses. They're trying to put it out with water. What you're going to see now is we add one more leg to what we call the combustible dust pentagon, and that's dispersion. The water jets that they're using have actually allowed the combustible dust that's already burning to be dispersed in the air below that vessel. And it creates this flash fire, right? You can see the power of it. You can see how these guys are engulfed immediately. Now, luckily, they're wearing their fire retardant gear, and they're able to survive this incident. But if, let's say, the firefighters aren't wearing their PPE, that could be a real problem. But this still isn't what we call an explosion. And the reason for that is that the explosion requires confinement. It requires a vessel, a building, or a compartment to be ruptured. And that comes from the pressure that's generated within that confinement. So this is going to be the key thing that we remember as we go through the hazard analysis process of the combustible dust story. So taking a look at secondary explosions, this is going to be another thing that gets widely talked about when it comes to combustible dust, because it's not the primary explosion that typically does a lot of the damage. It's going to be the secondary. Taking a look at this video, you can see the way that as the flame ball comes out of where it originates, you can picture that vessel there in the way far back the frame. It's very difficult to see where the flame ball originates. You can see that it travels all the way across this warehouse where you've got, fine wood dust being stored. And on top of those rafters, all that material is shaken loose. It falls into suspension by that pressure wave that precedes the flame front, and it's going to entrain itself into the air so that there's more opportunity for propagation. So What does that mean? We need to be careful about housekeeping, and we got to make sure that we're not allowing materials to accumulate. Fugitive dust accumulation is going to be a huge concern when it comes to combustible dust handling. As you can see in this photo on the top right, you can barely see the color of the vessel on the tops and on those diagonal slopes because of the buildup of combustible dust that you see there. Now, you may see 1/32 of an inch, 1/16 of an inch. These are different measures that are defined by the NFPA guidelines or other guidelines telling you how much you need to watch out for. Me personally, if I can write my name in it, if I can't see through that layer of dust to whatever the underlying equipment or handrail, whatever it is, that's when it's time to take a look at, all right, let's make sure that our housekeeping is in order and we're getting it taken care of. Finer particles are going to be the ones that are actually going to be more dangerous. As noted earlier in the presentation, the more surface area you have, the quicker combustion is going to occur, so the more dangerous that dust is going to be. It's those finest particles that are the ones that actually suspend up into the air, settle out onto the rafters above overhead equipment, and things like that. So, are there any questions regarding the basics of combustible dust? If you have any, please ask them here in the questions tab, and I can answer them later on the presentation. We're going to move on to NFPA and what the requirements are there. So those of you here in North America will remember that in 2008, when the imperial sugar explosion occurred, this happened, ironically enough, just after OSHA issued its first national emphasis program on combustible dust. The CSB, or Chemical Safety Board, and other agencies have been doing a lot of work collecting data on the loss history of combustible dust in our industries. And OSHA had taken note, put out its first national emphasis program prior to this explosion, and then reissued that national emphasis program after the imperial sugar disaster occurred. Now, since then, they've been citing the NFPA documents and the general duty clause as the ways in which they're enforcing this. Internationally, you may be looking at building codes, or you may be looking at some of, if you're in Canada, maybe your province-specific safety agencies. And they're also going to be focused on the NFPA standards. If you go over to Europe, you might be looking at the ATEX or some other standard in that way as well. But for that reason, we're going to focus on NFPA 652, which is the newest document that's been released with regards to combustible dust. It was originally published in 2015 and revised in 2018. Also, as part of the aftermath of this NEP that OSHA released, NFPA decided to put together what's called the Correlating Committee. And they're making changes to the industry-specific documents, making sure that everything aligns, making sure that everything's coming together and there's no contradictions, and that all combustible dust users are moving in the same direction. So when we talk about the requirements for NFPA when it relates to combustible dust, we're going to focus on a couple of things. First, you're going to determine whether or not the material you're handling is combustible, and you're using Chapter 5 to do that. Second, you're going to want to take a look at identifying and analyzing all the hazards that you have related to combustible dust. That's where the DHA comes into play. That's Chapter 7. Managing those hazards using a combination of engineered and administrative controls. We're going to take those identified fire and explosion hazards. We're going to do something about it. And then finally, we want to communicate the hazards to the affected personnel. We want to train our employees, make sure contractors are aware of what's going on. That's going to be the best way to prevent incidents moving forward. So there's two ways to determine whether or not your material is combustible or explosible through Chapter 9 of NFPA 652. The first is using industry published values. You can see here on the right, this is just a couple of the values that you might find for plastic dusts coming out of the NFPA 652 document. As you can see, they provide you with your Pmax and your KST data right there, and it lets you know what the median diameter of the particle was, so that you can make sure that the material that you're handling is going to be represented by that data. Now, the other way to do this, if you cannot find data that works well for you in the published values, is going to be to test your dust yourself. Now, this is going to be important, especially to make sure that when you test that dust, it's representative of what you're actually handling. You know, we don't want to necessarily just take a scoop out of the super sack that's coming in if there's a chance that the material could be degraded downstream, or that there's going to be mixing involved. You know, it's going to be very important that you work with us at DustCon Solutions or somebody else who's got knowledge of the specifics of combustible dust hazards to ensure that you're going to be testing this material appropriately. You can do it as received or per ASTM protocol. Those are things that you're going to want to get into. You know, do you have good control over particle size and moisture content, or should you be looking at a worst case scenario for your dust? Now, it's important to note that the absence of previous incidents should not be used for the basis of saying that my dust is not combustible. You know, just because at your sawmill you've never had an explosion doesn't necessarily mean that your wood is not combustible. It's just simply not the case. So when it comes to dust testing, I've put together a kind of a basic process flow map on how to go about it. The first thing you're going to want to do is determine an initial yes or no screen on whether or not the dust will ignite and will explode. From there, if it does, you're going to want to go ahead and do what's called explosion severity testing if you're looking to design things like explosion venting, explosion suppression, or explosion containment systems. You might also be interested in the ignition sensitivity, things like ignition energy, ignition temperature, explosible concentrations, or limiting oxygen concentration. These are all tests that you can use to determine either what are the consequences after ignition or what conditions are required in order to have ignition in the first place. And you can see some of the apparatuses that we use in our lab here to test these values. So a dust hazard analysis is the next part of that NFPA requirement in identifying and analyzing your hazards. Now, a dust hazard analysis is simply a review of your process, going through each point, each room, each vessel, determining where your explosion or fire hazards are possible, and identifying at what points you've got safeguards in place already versus where you need additional safeguards. Now, this process is the word dust hazard analysis was kind of coined by the NFPA 652 committee. It was done so in order to distinguish it from the process hazard analysis process, which is associated with OSHA's PSM. It is a retroactive requirement for all facilities, regardless of when the facility was built or what the standards were at the time. That means that all facilities handling combustible dust now must have a DHA completed by September 7th, 2020. However, in the food and the wood industries, those specific documents have carved out later dates for their constituents to have the DHAs completed. Additionally, you're going to want to update those DHAs at least every 5 years, or if you make upgrades to your system or add a new system. Now, I mentioned that a DHA is going to be different than the process hazard analysis that you'll find as part of OSHA's PSM, but it's also going to be more than just a walkthrough assessment that you might get with an explosion protection manufacturer. The DHA is focused on not only the equipment in the plant, but also on your administrative controls like training, like hot work permitting, things like that. So it's going to be kind of a little bit less detailed than what you'd find out of a process hazard analysis, but more detailed than just a walkthrough assessment. And like I mentioned, the steps to a DHA, we're identifying where the hazards are. We're going to evaluate what existing safeguards are already in place, and then measure whether or not those existing safeguards are adequate to meet the risk level that you're looking at. Recommendations are going to be made, and then those recommendations should ultimately be implemented. And we kind of do it in a cycle every 5 years. A dust hazard analysis should be done as part of a team. We want an intimate knowledge not only of the regulations, not only of the hazards themselves, but also of the process that's being analyzed. So for that reason, you're going to want to use your plant engineers, sometimes your operators, sometimes your maintenance, your safety staff, your administration. But you should always have somebody leading the effort who's what's called a qualified person. Now, a qualified person is kind of an ambiguous term set out by the NFPA. In their words, it's somebody who has experience with combustible dust hazards and has experience leading a DHA. So it's not like you can just go ask for a certificate from these people who might be offering to work on your behalf as the DHA qualified person. You really need to look at the credentials of the person that you're going to hire to do this. In most cases, it makes sense to hire an expert in order to assist in this process. The reason for this is that in many cases, smaller organizations just don't have the resources for somebody to be an expert in the field of combustible dust safety. So it's very important that you ask for references, for sample DHA reports, and check out the accolades that the person claims when they're asking to work on your behalf to complete a DHA. When we go through the DHA process, this gives you an idea of some of the more common places we're going to be looking to find hazards, at least when it comes to vessels that we're looking at. The data on the left comes from FM's property loss data sheets published in 2008. They show that over half of incidents involving combustible dust, fires, and explosions involve the dust collector. And the reason for that is that we've already got 4 of those 5 legs of the combustible dust pentagon given at any given time. And we're bringing in our combustible dust with air, our oxidant. We're enclosing it in the dust collector, and in most cases, we're using pulse jets to shake that, to disperse that dust into a cloud. So all it takes is that ignition source to get into the dust collector, and there you go, you've got your incident. Bucket elevators, mills or grinding equipment, storage silos and bins, spray dryers, these are all going to be very common places that we're going to be looking for combustible dust hazards within the process itself. And then over on the right, we've got a list of the ways that we can mitigate those deflagration hazards. You can think of things like explosion venting or flameless venting, which are passive approaches. You can look at explosion suppression, which is a way to put out that deflagration before it has a chance to build enough pressure. Oxidant concentration reduction, sometimes thought of as inerting, using like nitrogen or carbon dioxide or argon, something to keep your oxygen concentrations low enough that you can't support a deflagration in the first place. So what I want to do now is just quickly go through a example of how you might analyze one particular node within a dust hazard analysis. You can see here I've chosen a central dust collector pulling off of a blending or a polyethylene pellet production and blending process. You can see that we do have combustible dust being pulled into this dust collector. We've got it confined and suspended, as I mentioned, with the pulse jets. The MEC within a dust collector like this is almost always going to be exceeded because of the idea that those finest particles are being kind of recycled into and out of the filter bags. And then we take a look at what our credible ignition sources are. In this particular case, the additives used in the compounding process are going to have pretty low MIE, or minimum ignition energy values, meaning that the risk for static ignition is actually relatively high. If we have an electrostatic discharge, we could end up with ignition. So taking a look at what the safeguards that are already in place, we've got bonding and grounding and having the equipment located outdoors, kind of in a non-occupied area. Taking a look at additional safeguards needed, we're definitely going to be recommending explosion venting be used. If you cannot release the flame ball indoors for some reason, you're going to want to use either flameless venting, sometimes called quench tubes, or a suppression approach. And then you're always going to want to take a look at the inlet and the outlets for explosion isolation. Make sure that deflagration that occurs doesn't move upstream or downstream into interconnected vessels or pickup areas. Some other things to think about, you want to take a look at those procedures and make sure that hot work permitting is in place. Also, how well is this dust collector sealed up? Do we need to classify the area if there's lots of fugitive dust escaping, creating maybe a Class 2 Div 2 environment? Some other things to consider, we talked a little bit about housekeeping earlier in the presentation. Management of change is a big one I've not touched on recently, but managing your changes is going to be crucial in making sure that additional hazards are not added in between the DHA cycles. And then preventative maintenance is something that can oftentimes help to minimize the risk of ignition. Communicating hazards to personnel, always make sure that you're not only looking at your employees alone, but also your contractors. They should understand what the explosion protection systems that you have in your plant are, why they're important, and why it's important to follow the different procedures related to combustible dust and what the consequences might be. All of those things, when taken together, can help to minimize the risk that somebody takes action unwittingly to undermine those programs that you have in place. So here at DustCon Solutions, we offer a full range of services to help you with your combustible dust problems. Dust hazard analysis is the majority of what we do here at DustCon Solutions. But we also offer dust testing services, all of the tests that I mentioned below that we can assist you with, incident investigation, training, and some other analysis like vessel strength and PRED. So if this is something that you think you need, please give me a call directly. I'd be happy to help you. Other than that, I'd like to open it up to questions. We got a couple of minutes here before I got to let you go.